Hello guys, and welcome back to teach you differential equations. So in the last session we talked about homogeneous differential equations, and in this session we're going to go through specific cases. So the first case is where we have y prime is equal to f equation of line 1 over equation of line 2. What do we mean by that is, as you can recall from previous courses, equation of a line is in the form of ax plus by plus c over ex plus hy plus d. So now we're gonna look at different cases. Case 1, I'm gonna call this line 1. I'm gonna call this line 2 throughout this. So case 1 is where line 1 and line 2 pass through origin. Which basically means f of 0 is equal to 0. And how do we know that? As soon as the equation changes to f ax plus by and there is no third constant, we know they pass through the origin. So basically c equal to d equal to 0. Then it is homogeneous of degree 0. And you already know how to solve it. That's what we went through in the last lecture. So we simply do a change of variable y equal vx. However, the next one is what we are very interested in, which is case 2. Line 1 and line 2 are parallel. And if you can remember, two lines are parallel if slope of lines are equal, which in this case means you're gonna have y equal to f ax plus by plus c over ex plus hy plus d, and a over b is equal to e over h. Then they're parallel. What does that mean? It means it is not homogeneous. So how do we solve this case now? So again, I'm gonna rewrite case 2. So change of variable. We're gonna do a change of variable, and that would be u equal ax plus by. Doing so, it's gonna separate the two functions easily. Let's take a look. So example 1, y prime is equal y minus x over y minus x minus 1. Pretty simple. As you can see, these two lines are parallel. So I'm gonna define u as y minus x, so the first portion, right? And therefore u prime would be y prime minus 1 or y prime equal u prime plus 1. So let's replace back. U prime plus 1 is equal, and here y would be u plus x, right? u minus 1, and from here we can say u prime is equal u over u minus 1 minus 1, and therefore u prime is equal to 1 over u minus 1. Perfect. U prime is, again, du over dx, correct? So du over dx is equal 1 over u minus 1, which means u minus 1 du is equal dx, which is gonna tell me u minus 1 squared over 2 is equal x plus c, or u minus 1 squared is equal to x plus c. And knowing that u is equal to y minus x, there we go. This is solved easily. Let's take a look at another example. In the next example, we're gonna make it a little bit more complicated. So y prime is equal to x minus y over 2x minus 2y plus 1. Again, you can see that 2 over 2, which is 1, is equal to 1 over 1. So this is again parallel. I'm gonna make the change of variable like so. Does that make sense? And I'd like to always write this down for future reference. There we go. So we're almost done, correct? So we can say du over dx is now equal to u plus 1 over 2u plus 1. And then we can simply integrate. Let's just do it quick. Like so. And then if you integrate this, you will see that this is equal to u minus ln u plus 1 equal x plus c. As you can see, doing this change of variable will help us separate u and x. So let's take a look at one last example. Let's change it a little bit. So as you can see, this is my line 1 and this is line 2. I can simply rewrite this in the form of you see what happened? So I'm gonna take this guy to the other side and then separate it, which basically this is y prime. There we go. So now u is equal to 2x plus 3y. As you can see, again, 2 over 3, 4 over 6, this is parallel. Lines are parallel. So from here, u prime is equal to 2 plus 3y prime, right? And then y prime would be u prime minus 2 over 3. And from here you can also say u minus 2x over 3 is equal to y. So if I replace this, I'm gonna have u prime minus 2 over 3 is equal to u plus 4 over 2u plus 5, and therefore I'm gonna say u prime is equal 3u plus 12 over 2u plus 5 plus 2, which is u prime would be 7u plus 22 over 2u plus 5. Again, we know that u prime is basically du over dx, so therefore du over dx is equal to 7u plus 22 over 2u plus 5, and from here we're gonna have 2u plus 5 over 7u plus 22, du is equal to dx. And again, this is simply solvable. You can just integrate, and similar to the previous question, you can find the answer. This is how we're gonna solve the case 1, which the lines are parallel. So in the next case and in the next session, we're gonna go through the second case where the lines are cutting each other but they're not passing through the origin. Alright, see you guys next time.